Hi students, today we are going to discuss a topic on two transistor analogy of SCR. So you already in previous class we studied about what are the characteristics, that is dynamic characteristics and static variable characteristics of SCR. Now in this lecture we are going to study what is the two transistor analogy of SCR. So by using two transistor we can analyze the silicon control rectifier easily. So how it is we will discuss in this PPT, and also we studied about what are the ratings of SCR. So coming to two transistor analogy of SCR, with the help of two transistor analogy, principle of SCR operation can be explained. A two transistor model can be obtained by bisecting two inner layers of SCR. So what are the inner layers are present in the SCR? So we can combine these together. We can get two transistor model that's shown in this figure. So these are the two inner layers. So one in this one PNP transistors and junction J1 J2 and one NPN transistor, that is J2 J3. So we add together by this we can get two transistor model. This is the figure. So here we have PNP transistor and NPN transistor. So in between J1 J2 junctions there is a two currents flow, that is collector current 1 and collector current 2, that is cathode. And this equivalent circuit of transistor 2 model, we have to consider first transistor as Q1. It is a PNP transistor. So PNP means the emitter direction is towards the junction, and NPN means the direction of the intercurrent outwards the junction. So the second transistor is transistor as Q2. There will be collector current flow from Q1 to Q2. So the equation is expressed as alpha is the current gain. So IC1 equal to alpha I and IC2 equal to alpha 2 I2 plus ICO2. By applying KCL, we get these equations. So 1 and 2 we can write as simplification as anode current equal to IC1 plus IC2. So IA is equal to alpha 1 IA IC01 alpha 2 IAK plus ICO2. So when gate current IC is applied, then IK is expressed as sum of anode current and gate current give cathode current. So IA is finally equation as simple. From this we can realize the operation of SCR. If a small gate current is applied, IA increases with results in IE1. Hence the current gain is increases. Also IA increases, IE2 also increases. So IE2 is nothing but the cathode current, which is the sum of IA plus IG. So coming to SCR voltage ratings, so in forward voltage there are reverse voltage will be there. So VDRM, VDSM, VDWM, VRRM, VRWM, VRSM. So that is reverse recovery maximum voltage. So in this detail, VDM means peak working forward blocking voltage. It specifies the maximum forward blocking voltage. So VDRM is repetitive forward blocking voltage. It specifies the peak transient voltage. VDSM is peak surge forward voltage, and VRM is a peak working reverse voltage. VRRM is the peak repeater voltage, and VT is the on-state voltage drop, and VGT is the gate triggering voltage. So it is a minimum gate voltage to produce minimum gate current. VF is a voltage safety factor, and power dV by the maximum rate of rise of anode voltage that will not trigger the device without any gate signal. So finger voltage rating means it is a maximum value of the voltage. The current capability of SCR determine the temperature at its junction J1, J2, 3. So first ITAV is the average on-state current, IRMS is the RMS on-state current, surge current rating is both in non-repeated peak on-state current. So di by dt reading, this rating indicates the maximum rate of rise of current anode to cathode without any arm to SCR. So gate current is in between minimum value of gate current and maximum value of gate current. So and latch current, the minimum anode to cathode current to turn on the SCR. Holding current means after turning on the SCR, it should be in the conduction. That time we required as holding current. So IL is greater than IH. So coming to power ratings, we have average power dissipation, which is obtained during forward conduction loss and turn on losses and turn off losses. So turn off losses occur mainly decay of reverse current during the turn off process of SCR. So coming to reflection part, you have to consider the equivalent circuit diagram of two transistor analogy where it represents two transistors Q1 and Q2. One is PNP transistor and one is NPN transistor. So there will be two currents flowing, that is IC1 and IC2. From this we can simplify the gate current formula. So for the final equation, RL current is IA is equal to alpha to Ig plus ICO1 plus ICO 1 minus alpha 1 plus alpha 2. So IA is the anode current, alpha 2 is the current gain of transistor 2, Ic is the gate current, ICO is collector current of first transistor, ICO2 is the second transistor. So coming to some lecture level practice questions, you have to practice it. What is the two transistor analogy of SCR? So you need to define what is the latching current and what is the holding current of SCR. So what is the relation between these two? So latching current you already know, it is the minimum anode to cathode current to turn on the SCR. Holding current is to maintain the SCR in the on state we require some current, that is holding current. So thank you.